Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken, University of Albany, and Joel, Seth's brother. We're here to hopefully show you how to approach not only taking SAT math questions, but also how to approach studying for the test. One approach is to do as many Khan Academy questions as you can. Khan Academy offers free SAT practice, and Khan Academy was nice enough to partner with the SAT, and they broke the content up into about 40 topics. And it's a good idea to go through all 40 topics. They give you 20 questions per topic, about 800 questions. Sounds like a lot, but if you start early, you should be able to do them all. So we're going to start with question 16 on circular equations. We're not going to do the easier ones with the assumption that you'll go back if you want to. If you're not sure how to do circle questions, go back and do the first 15. In fact, just do the first 15 anyway, so you get really good at the stuff. The more questions you do, the faster you get. Good approach to the SAT. Anyway, here we go.
Well, I want to add something else.
Go ahead.
Second component of approaching studying for the SAT
Yes.
is to survey the topics of which this problem is on the topic of equations of circles.
Right.
And then check whether you know the basic facts in each topic. And when you look at, hey, I don't really know what the equation of a circle is, then go to any of the resources that you've had for learning math, and either properly learn if you hadn't done before, or review that topic.
Exactly. That's exactly what you do. And they're nice enough. We just take a second. They're nice enough to show you all the topics. See, I'm in. Wait, hold on. Everyone's dying to see this. You just go like this, and you see these are all the. Wait. Oh no, what did I do? These are all the topics. These are all the topics. See, Heart of Algebra. You got all these topics. Passport to Advanced Math. You got all these topics. Okay, you got them all right here. These are all the topics that Seth said. You look at them.
Well, where would they list the topic of the equation of a circle?
Right at the bottom, circle equations.
Oh, there it is, circle equations.
That's it.
Yeah,
circle equations. So then, look, they even give you a basic example and hard example. Look on the right a little bit. See?
Okay, so if you click on that, does it serve? Do they give you a survey of the facts?
No, they just give you an.
Oh,
give you a
no!
example.
What I'm saying is to look at the topic, then look at a problem in the topic, and see whether and assess for yourself whether you have learned or remembered the facts about what you read.
Right, of course.
And then if you find that you forgot those facts, or you never really learned them, then I think it's wiser not to bang at the problem with trial and error, but to get materials or ask questions to learn those facts.
Of course.
And we will see when we approach this problem, we will apply the basic facts about the equation of a circle.
Yes. And I forgot to also mention that when you start this, you will be starting at question 0, so you will not be able to get directly to the 15th question. I was wrong. You actually have to go through all 20 questions per topic if you want to get to the hardest questions, and you definitely want to get to the hardest questions so that you are really ready for the test. Okay, enough said. Oh my God, enough said today.
So let's do the problem.
Let's stop this silliness and let's do the problem. Today we only do one problem. Okay, here it is. A circle passes through point P. I see. Let me get my little thing working so I can annotate. Good. Point P. Okay. And is graphed in the xy plane, which of the following is an equation of the graph of the circle. So you have to know, it helps to know what the equation of the graph of a circle is in general. It's x minus h squared plus y minus k squared is equal to r squared, where hk are the coordinates of the center. That is very helpful with circle equations. That's the key point. This is the equation of a circle. Now they tell you the points on the graph, so you just match and see which ones are consistent. Which ones are consistent with this formula. So now, but you do have to figure out what the radius is. The radius is the distance from the center to a point on the end. So it's easy. It's a really good idea to consider the radius this way because it's easy to count the boxes. 1, 2, 3, 4, 5. Looks like the radius is 5. So these are the only 26. Are you kidding me? So 26. Are you kidding me? So r squared is 25. So these are the only two possible choices, and then you gotta be careful about the center, because the center is at -2, -3.
Okay, shall
So
we
this
show
is,
our audience how we are going to discover your mistake?
I made a mistake.
Well, continue. Let's see what happens.
So these
Keep
are
keep
so
keep
the
going.
x
Keep
plus
going.
2
Yeah,
squared.
what you're saying feels reasonable. It feels, it's kind of reasonable. Go on. See what happens.
I don't like the way Seth thinks Seth's playing with me, but Seth doesn't usually play around. Seth's a serious guy. This guy is like serious business. So I think it seems to be this one, but now Seth's scaring the daylights out of me. Because the radius does seem to be 5, unless I'm going nuts. 1, 2, 3, 4, 5. The radius is 5. So that means that r squared is 25. And the center of the circle is at -2, -3. So this would be consistent with that, because you have
I
to do
wonder
this
if you
thing.
could really, really blow up
You
the
really have to
view.
do this, okay? So you get x
If
minus
you
a
could you
-2.
really, really blow up the view so we get a real close up?
What, the radius is not 25? The radius is not 5? Oh, shoot. Are you kidding me?
I never kid you.
Oh, come on, SAT. Are you kidding? Oh, no. That's really. That is. Wait, hold on. Yeah. Oh, no. Wait. I'm trying to. There, I am blowing it up. Oh, are you. Oh, my God. Oh, my God. Oh, my God. Oh, bad news here. Oh my God, because to calculate the radius, honestly, you have to get the distance between these 2 points. I felt I didn't use a piece of information they gave me. Approach to the test. If you don't use a piece of information they give you, then you are doing the problem wrong. Oh, what a nasty thing. We have to calculate the radius using the distance formula here. Oh, well, we just care about r squared, right? We just care about r squared. So we make a little we make a little Seth Lakes when I draw smaller. So we make a little right triangle here, okay? And we want c squared or r squared. So we have to use that. So we use the Pythagorean theorem. This distance height is 1, 2, 3, 4, 5. Seth, how did you notice this? That's so good. And this distance here is 1, right? Because you go away from -2 to -3. So we use the Pythagorean theorem. 1 squared plus 5 squared. The Pythagorean theorem is c squared is a squared plus b squared. And that gives us the radius. So that gives us the hypotenuse, which is the radius squared. So it's 1 plus 25. Oh, God. Okay. Well, hopefully most people didn't do this, but good. You learn from everyone's mistake. So the big problem here was not using everything that was given. That should have been the key. Like you look at it, it's like
Well, I
they
think
gave us this information.
the big problem was that you were misled by what you thought the diagram looked like,
Right.
right? And made yeah, you made an assumption from reading the diagram that wasn't justified. And the assumption that the problem is you made the assumption. I gave you these coordinates. 3 here's the point 30 on the x-axis. You're at 3, and then you go down 1, 2, 3 integer coordinate steps, and you get to a grid point.
Yeah. Yeah.
The fact is that grid point with coordinates 3 minus 3 is not on the circle.
Right. Right.
You looked at it, it comes very close to being on the circle, but in the given circle and the given information, it's not on the circle.
Right.
However, besides the diagram, the facts that were given in the problem include that a particular point P that was marked with a black dot is said to be on the circle.
Right.
And I'll tell you what, the way I saw the problem, I noticed that point P was one integer coordinate step. One integer coordinate step to the left
Oh, right.
of point C.
Right. Right.
So
right,
I
right.
saw my eye was led to the 2 points that they told me are on the circle, and I noticed that line between the 2 points, which is guaranteed to be a radius, was not vertical or horizontal.
Right. Right.
So I said to myself, "Oh, I'm going to have to compute the radius."
Yeah.
That's a little tricky.
Yeah.
So then that's easy to compute the radius because there's this little triangle. This triangle whose base has length 1. And then I looked at the diagram and I counted off what the height was. 1, 2,
yeah.
3.
We did that. Yeah, we
4, 5. Yep. So I counted. Okay, I didn't do the subtraction. I just counted 1, 2, 3, 4, 5. Then I thought to myself, okay, the equation uses the square of the radius.
Right.
Right. So I didn't even bother calculating the radius.
Right. I know.
All I wanted was the square of the radius.
Right.
I said, okay, that's easy. It's easy to square 5 and get 25. And of course, the square of 1 is 1. Of course, that's 1 times 1. That's 1. So that's 25. So the square of the radius, also known as c squared or r squared, is 1 plus 25 is 26.
Right. Right. Well,
and then I noticed that the choices A and B, had the same provided equations with the same coordinates for the center, but the distraction was 25 versus 26.
Right.
And unfortunately, my poor little brother was distracted by the distractor.
Right. Yeah. There we go. That's right. That's right. Yes, I no, no, I wasn't distracted by the distractor. I made
You dismissed the distractor out of sight. You said, "Oh, can't be 26."
right. That what the fact that I
Just
was
because you thought it was 25.
now. I must say, let me say a few things in my defense, which is pathetic. This, if you are taking the SAT, if this actually was an SAT question, well, up until January 2024, it would be written. And depending on how they show it, don't forget, I'm looking at a screen that's very condensed. It may not, when they showed this question for real on a written SAT, it may have been more obvious that that point didn't exactly hit, right? Because, see, on the screen, it looks like it does. Now, that being said, watch out, everyone. Starting January 24th, 2024 in the United States, the SAT is going to be digital. So you're going to have the same problem I just had in that you may see it wrong on the screen. You are not going to be getting a written SAT. So you can't just look at it like this with your eyes. So, anyway, learn from everyone's mistake. I love when I make mistakes because I think it helps people. Right? And then hopefully when
Yeah.
you're doing the SAT, you're going to look at this and you can say, I'm not going to make the same mistake that guy made. I'm going to be careful
Yeah.
this time. And that's when we really become helpful because, as Seth said, if we get this wrong, the consequences aren't all that high. The airplane doesn't fall out of the sky. But think about this problem and make sure you don't do this on the real test. And I
Well,
would be careful
a
too.
clue is a lesson from this problem is is that is that if it's a geometry problem and they tell you about particular points with given names that are marked with black dots in the diagram, and they say what properties those points have, like point P is, what did it say? It's the first sentence says the circle passes through point P.
Right.
Point P is marked with a black dot, and its coordinates are given. When you see something like that, that should raise a warning. Don't assume. Be careful about
Right.
assuming that any other point,
Right.
that is not marked with a dot, that you think would be helpful.
Right.
That's some other point you might think
Yeah.
of. That does not mean that that means that some other point that you might think is close would not have the property that P is given.
Right. Right.
So so the thing is, your eye was led to that grid point.
Yeah.
And the clue that grid point coordinates 3 minus 3 might not actually be where the circle goes through.
Yeah.
The fact that they gave you a point and they gave you the name of the point and they gave the coordinates of the point should clue you that other point might not be on the circle.
But the other thing, and I don't know if people noticed in geometry, it is like you go back to all the geometry you did in whatever grade you did it in. Think of how many times in a geometry problem they gave you extra information that you did not use. Maybe in 2 questions on the entire year they did that. If you have geometry and they give you something, there's about a 99.9% chance that everything they give you needs to be used in the geometry problem. I always say that. And I forgot that thing that I always say, which means that people, you talk, you sometimes forget what you're saying.
Yeah.
I'm also educated as an engineer, so this answer is certainly close enough. Obviously, it's wrong, but in terms of designing something, unless it's major precision, like for a military thing, it's fine. Close enough.
It's about 2%. It's about 2% off.
Yeah. So in the scheme of designing something, something has to fit really perfectly. It's going to be a disaster, and you have to get a recall of the product. But
in modern technology, 2% is. So many things in modern technology, 2% is way too much of an error.
Right, I know.
The 19th century machinery when made things made of wood, 2%. Yeah, you know,
I'm still
it's not so
thinking from
bad.
back. I'm still channeling 19th century technology here. So anyway, but the bottom line is there are a lot of ways to avoid this, but a good thing to remember is that they give you a geometry problem, use everything, but you got to really be careful. And this is why this is question 16 of this section. I'm sure if we go back to question one, which we're not going to do, but if you go back to question one, it's not going to be this tricky. It's just going to be super straightforward and obvious, and much easier. But we're starting with question 16, so anyway, yeah, if you want to get to question 16, you don't have a choice. You got to start at question one. So, any other last thoughts? I'm
No,
embarrassed.
are you going to ask me how I got 2%?
Well, you're off by. I was gonna say. I was gonna say 1 out of 25, which I would have said.
That's 4%.
I know. So okay, I would have said, but now that's a that's 100% error because I said the error is 2%,
100% error
4%.
in the error.
Right, I said the error is 4% because 1 out of 25 is 4%. You said 2%, but I guess don't you have to be specific as to what the error is of?
In
Because you're not
linear
being very
measure,
specific
linear
when you're saying
measure.
the area. I mean, not the error. You're not being very specific about the area. I'm at the error. Is it the error in the equation? Is the error in the distance? Fine. Okay, I'm dying to know. But if anyone is done
Do
with
you
this
see what I'm
question,
writing?
yeah, the r squared plus the error, the square root. Yeah.
This is approximately r plus a half
Right.
of 1.
So you're saying the error in the radius.
When r is much, much bigger than 1. And here r is what? R is about 5. Right? Am I right? So,
Right. So
uh-oh, I think it's more.
no,
Is it?
no, Seth, you're just
Eh,
basically saying the
yeah,
error in the Seth. Wait, you're just saying the error is about 2% in the radius.
yeah,
That's what
yeah,
you're saying, right?
yeah.
Yeah, because but Seth, you don't have to go through all the theory. You just take the square root. Oh, come on, you just what's going on? You just take the square root of 26, and
Yeah.
then compare the square root of 26 to 5. And if you take the square root of 26, you get 5.099 compared to 5. So that's an error of 0.099 over 5, which is 0.099 divided by 5, which is 2%. A little
Yeah.
less than 2%. A little less than 2%. That is
Yeah.
1.98% in the error of the radius. So the radius is wrong by 2%.
Oh no, I made a boo boo here.
You're being too theoretical.
Yeah.
Being so theoretical. Yeah.
There's a boo boo here.
So, but the thing is, you can also do the calculation, right? This is the radius. Anyway, I think we are
It's equal to r
seriously done.
times 1 plus 1 over r squared to the square root. Yeah. No, that's it. Yeah.
Yeah.
Okay, so
Okay.
it converted a 4% error in r squared into a 2% error in r.
Right.
Yeah.
Okay, I could also tell something was going wrong because Seth was too quiet when I was using the problem. He's usually saying something, but he's too quiet. I should know. But wow, Seth, thanks for catching that mistake. Oh. So should we just do real fast just to see how they did it? I mean, they probably did it the
Sure.
standard way.
Well,
So
let's do
why
that,
not,
guys.
right? So let us do that. Check the answer.
Let's see if they give a warning about.
Yeah, if they basically say, hey, you schmuck, you got it wrong. Okay, what do I do here? I go no. Oh
That's the
yeah. That's something that the new SAT, by the way, I read about it. When they give you the digital SAT, you will be able to knock out answers that you don't like, that seem to
Hmm.
be wrong. I think that's what this means.
Oh,
Cross out. I think that's what this means. I think
oh.
so. But anyway, that's all detail. Okay, I think it's A, right? And then, of course, we didn't really go over the center of the circle, but I did at the beginning. Didn't make a mistake there.
Well, the
Okay.
trick there,
Uh oh.
what's the pitfall?
Now, the pitfall is making mistakes with a negative sign.
Yeah,
Um,
H and K.
yeah, have to be negative. Yeah.
H and K appear in the equation in their negatives.
Right. Yeah. Well, I sort of went over that.
Yeah, well,
Uh,
let's do it for fun.
okay, fine. You do it. You do it the Seth way.
And this is the expression. And so the center is H, has coordinates HK. Now,
Right.
the coordinates of point C, H is -2,
Yeah.
and K is -3.
Right.
And then when you plug the -2 into the H here, you get X minus a -2,
Right. Which is x plus 2.
which is X plus 2.
Yeah.
Okay. Now, the way I check this is that I know that at the center of the circle, the left-hand side is 0.
Yeah. Oh, right. Yeah.
And,
Yeah.
and so I said, okay, this is the X plus 2 is the expression for which when X is -2, you get a 0.
No, that's a smart way of doing that. I don't know if I
And
noticed
Y
that.
plus 3 is the expression for which when Y is -3, he gets 0.
That's a really good idea, actually. That's a really nice way to check it. That's great. Wow, that's good. That's a great insight. I'm glad anyone who was lucky enough to listen to this video longer than we should have spoken just got a really good insight there. That was really great. That's really good. Okay, check answer. Let's see. Boom. And then I guess we need to
Well, let's look at how they explain it.
clear all. Okay, here we go. Clear all. First, we got it right. That's good. The formula for the circle with center HK. Notice they make the H and the K like colorful, which is nice. We already know the coordinates of the center are the coordinates of a point that passes through. The distance between those points is the length of the radius. Notice they are calculating the radius at square root of 26. Completely unnecessary because you're going to be using the square the radius. But why not? They want to be consistent with what they were doing, and then they get the answer. Notice they don't warn you. They say, hey, jerk, you make sure you don't make this mistake. I wish they did. Sometimes they tell you in the SAT, they tell you what. They do tell you what's wrong. This equation suggests the radius is 5, but the distance between P and C is not 5. They should have said, even though we'll look that way, and
it
we
doesn't
purposely
suggest the equation B is the equation of the circle whose center is point C and whose radius is 5.
That's right. That's right. But the distance between P and C is not 5. But they should have said, even though it would look that way.
So they should have said equation B is the equation of a circle whose radius is 5.
Yeah.
But the radius of the given circle is not 5.
That's what they said. But they said the distance between P and C is not.
No, it says the equation suggests that the radius is 5.
Oh, yeah. Well, then maybe you should get a job at Khan Academy to make it a little
I'm
better.
retired. I don't need it. I don't. I'm not inclined to get another job.
Okay, no, but hopefully by us doing this, and anyone who listens to it will get the benefit of Seth's insight, where you really want to understand what's going on, and that's the other approach. You really want to look at problems and look at it from all the different facets, and just spend some time thinking about how the problems are done and what mistakes you made. Okay, so that really does it. So please like us, dislike us, give us comments on our YouTube video, or email us your comments at satmathquestionoftheday@gmail.com. And if you have any SAT math questions, email them to us at our email address, satmathquestionoftheday@gmail.com. I guess that's
Well,
it, right?
I some more criticism
Uh-oh.
of their explanation. For
Okay, okay, go ahead.
C and D.
Yeah,
Well, see, they rule out C because the equation in C is the equation for a circle with a center that's not the given center.
okay.
Well, equation D should also be ruled out for the same reason as C. So
Wait,
equation D is for a circle that whose center is different from the given circle
right.
and whose radius
Oh,
is
yeah,
different from the
right,
radius of the given
right,
circle.
right, right. Yeah, yeah. True, 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 true. Yeah, yeah. Okay.
And so what you did, what Joel demonstrated at the beginning of the problem was that he immediately ruled out C and D because they were equations for circles with the wrong center. He didn't even look at the 26 and the 25.
No, no, no. I did the 26 and 25 first, and then I looked at the center. That's not true.
Oh, okay.
That's
So
not
either
true.
way, yeah. So you do
That's
this,
not true.
yeah, yeah.
That's not true. That's not true.
So you could do either one.
Yeah.
You rule out the well, do it correctly. Do it correctly. You'd rule out the 25s, and then you'd among the ones that are left, you'd pick the one with the center is of the equation. The center for the circle of the equation is the center that's given in the problem.
I mean, the other thing I should have done was the other way to do it is do these two first and rule these out, and then you ask yourself, why are they even bothering at this 26? Is this a trick question? Be ready for tricks, right? You can
Yeah.
think, what is this? Why did they even put a 26? What was their even
Um,
reason for putting a 26?
because they needed to put it there so that there'd be a choice that's the correct one.
Yeah, this is weird to have the two be so close to each other. So maybe there's a trick, and that could alert you to wake up and say, there may be a trick in
Yeah.
this, and then you be careful not to make the mistake I made.
Mm.
Oh,
Yeah.
God. I hate making mistakes, but that is part of math, and that's where you learn.
Mm.
So it's okay to make mistakes. You just want to sort of hit yourself a little. Okay, that really is it for today, right?
That's it.
That really is it. Like, we are really done. Okay.
We're really done.
We really are done. We killed this problem. Okay, so it'll be a while till we do another circle problem. Okay, everyone, have a great day. Bye bye.